Hello there. Welcome back to our channels. It's been a long time we are meeting, and this time on your screen, I have a transistor which is using NPN transistor, as you can see on the schematic, and this is a voltage division bias circuit that I have used for this circuit. So I have this positive supply and then there is a ground or common terminal. Resistor R1 and R2 use the voltage division bias circuit. Remember, there are three types of biasing: fixed bias, collector to base bias, and potential division bias. So third one is what you see. And then I'm using, let's say, a capacitor C1 and C2 to couple the AC input to this transistor. That's why the name of the circuit is called as AC coupled difference amplifier. And in our previous modules, we just recently covered the topic of difference amplifier or differential amplifier, where we symbolically represented the amplifier in this way. We said there is a V1 and V2 as two inputs, and the difference between them is called as VID, and the output of such amplifier is gain times VID. We said like that. So here you see there are two inputs required, but the topic here today is to give you an idea about how a single transistor can also be used as a difference amplifier or differential amplifier. So what you are seeing here, at the base, I am applying this signal, let's say V in 1. Let me call it as a V in 1. And at the emitter of the transistor, I am applying another signal. Let's call it as a V in 2. And here are my pins that are right. This is my base pin, this is a collector pin, and this is an emitter pin. And there is a junction voltage drop called as VBE. Let's say this is VBE, which is going to be the difference between VB minus VE is my VBE. And VB is assuming that at the signal frequencies of interest, the capacitors we choose with a very large value or large enough value so that they act as AC short at the signal frequencies of interest, and then our input gets coupled to the respective pins. So at VB, I have V in 1, which is varying from positive to negative, and at VE, I have V in 2, which is varying from negative to positive. Okay, and that's my applied signal as a difference signal, as you can see right here. And the transistor job is to amplify those signal with the gain. And first thing that we see, the output of the amplifier, if we say the V in is applied only and V in 2 is AC grounded, so output due to V in 1, we can write here, let's say V out is equal to GM times RC. Remember, IC and GM is the transconductance and RC is the load resistance. So that becomes your gain multiplied by V in 1. So this is the output that you get, and this is a common emitter amplifier. Remember, there is a minus sign because it is inverting amplifier. So this is CE amplifier, that is common emitter amplifier. You are applying signal to the base, emitter is grounded or through these resistors, and then collector is where you take the output. Then if you AC ground this signal and apply V into with the signal phase as shown, you have a signal that is called as GM times RC times V in 2. That is your output. So this is typical a common base configuration, and you call it as a common base amplifier. Why you are calling it common base? Because you are AC grounding the base pin. That is why you said that Vn is grounded, and applying a signal through this capacitor that is V in 2, and taking the output at the collector, that is V out. So you see, this is your inverting amplifier because there is a negative sign, and this is your non-inverting amplifier, right? So if you have a positive going input here, your output will be like this with the amplification factor, of course. And if you have the negative going signal like this, then your output will be just opposite, in phase to this signal, okay, and opposite to this earlier drawn signal. Now, what about the input impedances of this circuit? And before I explain you the input impedance of the circuit, remember, you are basically, this transistor is called as difference amplifier, and it is AC coupled because we are using the capacitors. And this is a difference amplifier because you are, this transistor is amplifying the difference between the voltages applied to its base pin and the emitter pin. If the voltages applied at the base pin and the emitter pin are in phase, for example, this is positive going, and at the emitter pin also the positive going, in that case, your V output is likely to be 0, of course. Now, what about the input impedance of the common emitter amplifier? So remember, for a common emitter amplifier, right here, for CE amplifier, we have the input impedance Z in is very high. Okay, and we look in this way, Z in right here. And for the common base amplifier, base amplifier, your Z in is low. We are looking at the input impedance of the circuit from this end. Okay, and so there is a way to utilize this properties of common emitters, high input impedance, and common base low input impedance. So you can think about utilizing those properties. Okay, so I hope you understood the concept about how a single transistor can be used as a difference amplifier. And with that, we would continue our discussion about the differential amplifiers. We will explain the differential amplifiers with active loads. We have just covered the differential amplifiers with the long-tailed pair. So refer to our previous modules. We have a lot of interesting tutorials there. And stay tuned. Subscribe to this channel if you're new. And if you like this video, click the like button. Put some comment based on your opinion, what you feel. Share it with others for a wider reach, and wish you all happy learning.